I am Muhammad Mustaqim bin Jamaluddin.
Hi, I am Muhammad Syamil bin Zulkifli.
I am Muhammad Syarif Pak bin Muhammad Siddiq.
I am Muhammad Syamil bin Syarun.
I am Muhammad Luqmanul Hakim bin Azim.
This is Muhammad Nasmi bin Zalullah.
We are from Group 5.
Hi, I'm Shami. So our group will develop a program about a simple binary calculator that is able to change any number in binary form into the two base forms, which are octal and hexadecimal base numbers. This will help to change any number to any base in a short period. From other perspective, it can make a user have fun while using it due to its ease to use it. Thank you.
Hi, I'm Muhammad Mustaqim and I'm going to present about IPO table. So, what is IPO table? Input Process Output Table, or IPO table for short, are an effective way to model the important processing going on in your system. There is three parts in an IPO table. The first part is input, which is the data is required in order to create the required outputs. Second is process, which is the steps involved in creating the outputs from the inputs. Some simple coding does not require any process, as nothing can be processed in the coding. It just goes straight from input to output. The last part of an IPO table is output, which is a piece of information which we want. For our assignment, the IPO table goes like this. In the input section, there's any binary, octal or hexadecimal number. In the process section, you need to select case for conversion. Binary to octal, octal to binary, binary to hexadecimal, hexadecimal to binary, and enter the number base that you want to convert. And lastly, at the output section, is display the conversion result.
Faiz, I want to talk about procedural code about my group. We include the outstream using the space STD to enable the program basic input and output operation, and we put an intermain and we put an integer choice to user to choose the base. User can press 1 to choose binary to octal, octal to binary, press 3 binary to hexadecimal, then press 1 to hexadecimal to binary. And you can see what is selection in the program. Okay, next we make a case 1 to change the binary number to the octal number. And first we see out enter the binary number to user enter any number, and we put the formula to change the binary number to the octal number. And the user can see equivalent octal value to see octal value. Next, we make a case 2 to change the octal value to the binary. First, we see out the enter the octal number to user enter any octal number to change to binary. Next, we put the formula to change octal number to the binary number, and the user can see equivalent binary number because we see out the equivalent binary number. Okay, my friend will continue.
Hi, my name is Muhammad Nasmi bin Zalullah, and I'm gonna talk about procedure code case 3 and 4 for my group. For case 3, I will talk about how to make a procedure code to create a calculator that can change binary number to hexadecimal number. First, we put cout into any binary number and then cin binary number. Next, we will put the formula into the procedure code, and the user can enter any binary number so it can be changed into hexadecimal number. Finally, the equivalent value and hexadecimal value will pop up. Next, I'm gonna talk about case 4 and that is a calculator that can change hexadecimal number into binary number. First, we put C out into the hexadecimal number and then C in hexadecimal number. Then, we put the formula into the procedure code and the user will have to enter any hexadecimal number in the programming code. Finally, the equivalent binary value will pop up. That's all from me. Thank you.
I would like to share about binary to octal flowchart. And for the diamond is j more than 0. If it's true, then I equals to I times by 8 and n equals to n divided by 2. And the output for that will be j equals to j over 2. The first one is the circle, which is the start. And the second one is for input, which is enter octal number. And then for the last circle, it is the end. And from the diamond, if it's false, then the output will be binary is 0, which is B. The next flowchart is for octal to binary number. For the first shape is the circle, which is the start, and the second shape is declaration. Declare P equals to 1, decimal equal to 0, binary equals to 0, I equals to 1, J, D. And for the third shape is the input. You have to put the number. The next one is the diamond shape. If I equals to 1 and it is true, then it will be P equals to P times 1. And if it false, it will be P equals to P times 8. And for the next shape is decimal equals to decimal plus D times P. For the next shape is to declare that J equals to num and D equals to J percent 10. And if it's false, then it will be J equals to J divided by 10. And for the next shape is J equals to J divided by 10. And for the next shape is binary equals to binary plus decimal percent 2 times by 1. For the next shape is diamond. If J more than 0 and it's true, it will be J equals to number, D equals to J percent 10. And for the next shape is J equals to J divided by 2. And the next shape is diamond, J more than 0. And for the next shape is the output, which is print binary. And I equals to I times 10, decimal equals to decimal divided by 2. And the last shape is the circle, which is the end.
Okay, so I'm going to talk about flowchart. Okay, a flowchart is a diagram that depicts a process system or computer algorithm. Okay, they are widely used in multiple fields to document, study, plan, improve, and communicate often complex processes in clear, easy to understand diagrams. So we move to the nearly to hexa. First start, and then we go to the process, which is initialize integer. Then we go to read A, which is the input. After that, we go to the process, which is integer equal to 0. Then if it false, we go to the call sub program complement A. If it's true, we go to the decision, and then if the decision is false, go again to the process. If it's true, number is not valid. After that, it stop. So we move to the hex to binary. Okay, before we learn how to convert hex to binary, let's understand how the base 10 system works. Okay, the decimal are also known as the binary or base 10 numbering system that we use in everyday life, make us of 10 symbols or numerals. It is 0, 1, 2, 3, 4, 5, 6, 7 and 8. So to count, you can start with the 0, then continue 1 until 9. Okay, so first we write down the hex number and represent each hex digit by its binary equivalent number from the table above. Okay, so we use 4 digits and insignificant leading zeros if the binary number has less than 4 digits. Then we concatenate or string all the digits together. Then discard any leading zeros at the left of the binary number.
Closed doors, I'm a fool for your love.